Yes, so hello friends, this is the video tutorial for today's POTD on Leetcode, which is unique length 3 palindromic subsequences. Just an FYI, in these POTDs kind of videos, I will go a bit more in detail and it would be more beginner friendly rather than the contest discussion, which like if we are discussing a hard problem, we cannot go in detail about the problem. So yeah, these we can go in detail. Most of the Leetcode POTDs I find are quite easy and quite simple to solve. So we can begin on this question now. So what the question says, the title is Unique Length 3 Palindromic Subsequences. What the question is basically asking is, you're given a string S, find the number of unique palindromes of length 3. So this thing is important that the length of the palindrome would be 3. That are subsequences of S. Okay. What is a subsequence? So if you don't know, we can go over it. So let's say we have the string ABBAC. So like substrings are that if you are starting from this index, like this next index has to be the next one, like it has to be the neighbor of it, or it has to be adjacent to it. But subsequences does not have this criteria. If we are starting at this, the only criteria that we need to follow is that we can go to any other index after it. So let's say this is our start index. So we can pick this index, or it's not necessary. We can skip also this index and this also. So this we can pick, or and then we cannot pick. If we don't want, we do not need to pick this also. So APA, is this a subsequence? Yes. So mostly you can get the subsequence by deleting any number of elements in between. So let's say if we want to find all the subsequences of this, let's say we do not do any deletion. So that would be ABBAC. Is this a subsequence? Yes. Okay. Next, let's say we delete this, so the string we'll get is bpac. This is also a subsequence. If we, let's say, delete this a, we'll get apac. This is also a subsequence. So like deleting like all, so delete, like if we do this deletion, we get this in pac. This is also a subsequence. So hopefully this makes sense. I think like you can go and look up what are subsequences if this does not understand. If you do not understand even now what are subsequences, the basic criteria that you need to remember is that it is not necessary that the next element of the subsequence would be the adjacent one. It could be any element after that element. Okay. So note that even if there are multiple ways to obtain the same subsequence, if it is still counted out only once. So what this part basically means is, let's say we have this A, B, B, A. Now one palindrome subsequence of length 3 would be this ABA. Palindrome is basically a string that reads same backwards and forwards. Right. So this is one way to get this ABA palindrome, but another way is like picking this A, picking this B, and picking this A. So again, the palindrome would be same ABA, but the way like the indexes we picked is different. But what the question says is this and this palindrome is counted as same. So we basically need that. What are the length, not the indices that gives us a palindrome, but what is the exact string that is a palindrome. So that is what is meant here. Note that even if there are multiple ways to obtain the same subsequence, it is still counted only once. Okay. Now the question talks about what a palindrome is. We can look up this. What a palindrome and a substring is. A palindrome is a string that reads the same forwards as backwards. As I said, a subsequence of string S is a new string generated from the original string with some characters can be then deleted without changing the relative order. So this is what I meant by the deletion definition. For example, ACE is a subsequence of ABCDE. So ABCDE, we delete this, we delete this, and we get ACE, which is a subsequence of this. Huh. Hopefully this makes sense. Let's go over how to approach this solution. Now the important part here to see is, let's use a different color. Okay. Let's use this. Okay. So the point you need to notice here is that this thing, that even if a string can give you the same subsequence, let's say the palindrome, let's say the palindrome is ADA, like let's say there are 10 different occurrences of this only gets counted as one. So why this is important is, let's say we have this string A, B, A, C, D, A, B. Okay. So what would be like the format of a length 3 subsequence, length 3 palindrome? So a length 3 palindrome would have this three lengths, right? And it has to be a palindrome. So this character has to be same as this character, right? Because then only it would be a palindrome. So if this character, let's say, is some x, right? This has to also be x. Now this character could be any character y, right? So this is the format of a length 3 character. So for example, a, if x is a, now for any y, this would be a palindrome. Like you can put any character from a to z. This is a palindrome because it reads the same forward as it reads backwards. Hopefully this makes sense. If this makes sense, what we can see is that okay, the only thing changing, like for all a palindrome, is two characters. That is the first character and the second character. The third character that is determined by a first character, like for all length 3 palindromes, right? If this makes sense, then what can we do is go over all the characters that x can have, go over all the characters y can have, and see and generate all those palindromes. Basically, what I'm saying is, what is the total number of possible palindromes? Like that is basically what is the total number of characters in x, what is the total number of characters that y can be. So we can see here that question in the constraints. Let's take a screenshot of the constraints also. Okay, let's do this. Hmm. So yeah, what I was saying is, like it is mentioned here. Okay, where is, yeah. It is mentioned here that S consists only of lowercase English letters. So that is x can have up to 26 values, y can be at most 26 values. So our total number of possible palindromes is 26 square. Now this 26 square would generate me all the palindromes that is possible. Now we need to check, is that possible palindrome in this subset. Like let's say we generated this palindrome, like the first palindrome will generate is triple A, right? So that is x is a, y is a. Then the second palindrome will generate is ABA, then ACA, and so on, right? Now we need to check, is this part of the string, is this part of the string, and so on. Now how can you do this? Like you can do a simple traversal of this array, and then what you can see is that, like, how you find a subsequence of this is basically, let's say if you are at, you maintain two pointers. Now let's say this and this matches, so you move both pointers. Now it doesn't match, so you only move this pointer. Then this matches, so you move both pointers again. And this doesn't not match, so you only move this pointer. Then this and this doesn't match, so you only move this pointer, and now this and this matches, and now you do not need to match it anything else. So yeah, this means that this is a subsequence of this. And what would be a time complexity of this approach? So you are doing a traversal on the array, right? On this string, sorry. Okay. Yeah. So that would be like the time complexity would become 26 square n. So 26 square n is around 10 raised to power 5. That is 26 square into 10 raised to power 5. So we can see that 26 square is around 676. Okay. So this would be 676 into 10 raised to power 5, which would be 6.76 into 10 raised to power 7. So this would work. It would work. It would get an AC, an accepted solution, because see, it is less than 10 raised to power 8, and like even a lot of 10 raised to power 8 solutions works. Depends on what the exact data structure you're using. Get an AC. We can code this out as well, but let's see if we can find a better solution than this. Okay. So okay. So the time complexity here was 26 square n. Let's see if we can make this better. Can this be bettered? So let's think how we can better this again. Let's focus on this pattern of a palindrome xyx. So rather than like generating all the possible, like we generate all the possible palindromes and then check if this is a valid palindrome, or this palindrome in a string is. should we do this in reverse? What I mean by that is, like, we know our s, so we can check that, okay, if x is this character, let's say x, we have set x to b, so this would also be b. So now let's check what all values y can be. So what I mean by that is, like, let's take this string. What was this? A B A C D A B. A B C D A B A C D A B. A B A C D A B. A B A C D A B. Okay. Now, okay, this is fine. So RP is this character. RP is this character. Let's say we also have another P here. So A B. Right, we have these three b's in our characters. Right, now we can check what all characters are between this, because see, we need a subsequence. We have set one character here, we have set one as here. Like, let's say we say that the first character of the subsequence would be this, the last character of the subsequence would be this, and then we can say what all characters are in between it. Is this the best way to we can do this? No, because see, the best way would be that you pick the first character of this x, like whatever the x is, you pick the first occurrence of it, and then you pick the last occurrence of it, because that would have the most amount of characters in between. What I mean by the most amount of characters in between is, see, if we pick this character as the last character, the subsequent the palindromes we would be able to generate is BAB, BCB, BDB, right? That is all the characters in between. But if we pick this one, these all will always get generated, because see, these characters still in between, but we'll also be able to generate B, 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 and BAB. But see, BAB gets repeated here. BAB gets repeated here. It should only count once. So what we actually need is number of unique characters that is in between these two characters. So what is a strategy now? A strategy now is that for x in A to Z, let S be the first occurrence, uh, or basically occurrence of x 0. Let L or end be the occurrence of x last occurrence, basically dot back, we can say dot back. Now, what will add an answer is number of unique character in between S and E, right? In between S and E. So how we can maintain this index, like this vector, which would have all the occurrences of x. Then what we need to find is number of unique characters in between S and E. There's two ways to do this. One simple way is that we can just traverse the array. Like, we know this traverse the string, we know this first occurrence, we know the last occurrence, we can just traverse it and then maintain a unordered set or a set, and just like add each character and add to an answer, which is the size. So what would be the time complexity of this? It would be like this loop will run 26 times, and then this traversal at worst have will be done n times. So now our complexity is 26n. This looks much better than this 26 square n, even though this works, but this is a better solution. The other way to do this also is maintain a prefix frequency. So what this prefix frequency basically means is, like, where's a string. So this is a string, right? Yeah, this is a string A, B, A, C, D, B, A, B. So what this prefix frequency would be is a vector of vector or a 2D array, where, like, prefix prefix frequency of x comma y is basically like, or rather I comma j. Let's use that. This would make more sense. So what is the frequency of j, or the character j basically, in 0 to I? In 0 to I, how many times this occurs? So basically we can like drag in this here. So like, let's say this is a this is a 2D array, and this is frequency of A, this is frequency of B, this is a D, C, D, and so on, like till Z. So A comma, this would be 1, 0, 0, 0, because see, A occurs 1 here, B does not occur, and C does not occur, D does not occur. Now in this part, A occurs 1 times, B occurs 1 times, C occurs 0 times, D occurs 0 times. Now this would be 2, 1, 0, 0. This would be 2, 1, 1, 0. So you can generate this prefix frequency. Generation of this would be 26n. And then how you can use this here is basically like we need to check what all characters are between S and E, right? So what all characters are in between S and E is basically prefix frequency of E minus 1 minus prefix frequency of S. Okay. Prefix frequency of S. So this is basically the frequency, or this would give me the frequency of each character in between. So this would be like my frequency vector. And then we'll basically do a check like frequency of each character for Y in A to Z. Yeah. So, if frequency of Y is greater than 0, we'll add it into answer plus plus. So what would be the, like we saw the first approach that would give me a 26n. What would be the approach, the time complexity here? See, this is just an O of 26. Like this doing a minus would be 26, and then going over all the characters is 26. So this would actually change a time complexity to 26 square. But that would be only for generating the answer. The first part, that the generation of prefix frequency, would still be 26n. So this would also be a 26n solution, and this is also a 26n solution. Yeah. This would also be a 26n solution. So this I think is a bit simpler to like maintain. Like that, you just do a traversal of the string, and in this you need to generate a prefix frequency and all of that. So we will do this solution, and let's code it out. So what I mean by this solution, basically for each character x in A to Z, we'll just find the first occurrence, we'll find the last occurrence, and then just traverse over all of them. Okay. So yeah, let's go to the coding part. I will live code it, and hopefully it would work. So yeah. Okay. First we'll just store the, in n we'll just store the string size. Then we need to maintain like the occurrences to get the last occurrence and the first occurrence of each character. So this 26 for int I equals to 0, I is less than n. So now we are traversing over all the characters. Again, see, a character, how do you map a character to an index? So let's say you have this character y. This would be basically what, 24, right? If a is 0, b would be 1, c would be 2, and I think this should be 24, right? So how do you do this? Is basically you get the opcode or ASCII code of this, and you subtract it with the ASCII code of a, basically because we are saying that a is 0. So because a is 0, now this would become y, and the ASCII code of y minus ASCII code of y, it should give you 24, and this would be the like the integer representation of this. So what I mean by this, to get the integer representation of this, is just re- remove that character's ASCII value. Sorry, remove the a's ASCII value with the with the ith character's ASCII value, and then you just do occurrences of x dot push back I. So that basically means that this character X occurs at index I. Now, now we'll do the answer generation. So how you can do this is for int c equals to, or rather x equals to 0 to x is less than 26. For each character, we get the first index. Rather, what we should check first is this character even occurring? We'll create an answer variable here. So what we should first check is that is this even occurring two times? Because if this does not uh, occur two times, like see, if it was a string, it was here A B A C. Okay, all the characters are occurring now. See, C is only occurring once, unlike characters like Y and T does not even occur once. So for those characters, they cannot never form a palindrome because your palindrome is of the form x by x. So this x has to occur two times. So yeah, that we added a condition here that if this character is at least occurring two times, then only proceed. Otherwise, don't do anything. This cannot give you a three-length palindrome subsequence. Now we get the first index of this, which would be occurrences s0. Then we get the last occurrence of it. Last would be occurrences s dot back. Occurrences s dot back. That is fine. Now we can just traverse over this part. Int j equals to f plus 1 and j is less than l. Because see, we need the characters in between. Let's say for a we do this, so a is this. We should remove some of this. First occurrence is this, last occurrence is this. We need all the unique characters in between this. Right. Okay, sir. Okay. And what data structure can we use here to get the unique characters here? There are a couple of ways to do this. The simplest way is you can use an unordered set, but I do not like to use set because in competitive programs, unordered, like any unordered data structures, can lead to TLE. You can read about this. It basically leads to collision because because of hashing. So hashing leads to collision. In Leetcode, it never happens. I've never seen it like due to using an ordered set, you are getting a TLE, but in competitive programming it does happen. So I just like to use sets here. So set of characters, let's name this st, and yeah, let's get y. Similarly to what we did here is we convert this sj into this sj character into an index, and then okay, this is already a character. This is already a set of characters, so we do not need to convert it into an integer. We can just do st dot insert s of j. S of j, that is fine, and just do answer plus equals to st dot size and return answer. Let's run this. Okay, we get a compilation error. Why do we have this? Okay, x. This should be x, not s. And this also should be okay. X. I do not know why I put s here. Yes, so this works. And let's submit it, and it should get an accepted. We do run like we are having a lot of time complexity. And that is because I think if I just change it to an ordered set, this would reduce this runtime. Okay, and then I misspell unordered set declared here. Let's do this. Okay, yeah. You can also optimize this even more, like rather than having a occurrences, full occurrences array, you can only maintain like two vector of pairs, basically meaning the having the first index and the last index of it. Or you can create two vectors. So because see, we do not need the occurrence in between. We just need the first occurrence and the last occurrence. Yeah, hopefully this makes made sense. If you like this, you can subscribe, all of that. I will try to upload more videos and be more consistent. So that's it. Thank you for watching. Bye bye.